Here, I'm going to show you how we find probabilities using the standard normal tables. We will be using this table. So let's see how we find the probabilities. To be able to find the probabilities, we first need to standardize the variable x. But for now, we're going to focus on finding probabilities after standardizing. And in the next video, I'm going to show you how we standardize the variable x. So as you can see here, I have a few normal curves and I'm going to show you how to find different probabilities. So let's start. We have a first normal curve and you can see that I have z here and you have a shaded part. We need to find the shaded area where this area gives the probability that z is less than a particular value z. We need to find what? The probability that the standardized variable z is less than a particular value z. We simply take phi of z. It means that we're going to use the normal table to find z. Note that z is on the upper tail, which means that we need to have a positive value of the small z. That is, for example, if I have to find the probability that z is less than, suppose 0.16. First, we locate this z. We know that z is positive, so it has to be on the upper tail. So here my z is 0.16. And we need to find the probability that z is less than 0.16. So directly we're going to take what? Phi of 0.16. Next we're going to use the table. So 0.16. We have 0.16. 0.1. So we look for 0.1. We have it here, 0.1. And then after 1, we have 6. So we need to move along the table till 6. So we can see that we have a probability here. We have a value here. So this becomes my probability, which is 0.5636. So there we have it. The probability that z is less than 0.16 is this. So we have a first formula, which is probability of z less than z is simply phi of z, given that z is positive. This is our first formula. Next, this time you can see that we have to find the shaded area here where z is positive. Suppose we need to find the probability that z is greater than 0.874. First thing to notice is we have a positive z, which means that z is going to be on the upper tail. So this is the upper tail, this is the lower tail. So if z is positive, it's going to be on the upper tail. Later we're going to see what happens if z is on the lower tail, right? But for now, let's focus on positive z. So we have z greater than 0.074. The total area under the standardized normal curve is 1, right? And we know that the probability that z is less than z. So we know that this probability is what? Phi of z. But we need to find this part, which means we're going to take 1, which is total area under curve, minus the phi of z equals 1 minus phi of, we know that our z takes 0.874. We need to use the normal table. Okay, so let's see. We have 0.8. Let's look at 0.8 on the first column. 0.8. The next is we have 7. 0.8. And then we move along till here. we have 7. Now we can see that this value of 7 here gives what? 0.8078. But after 7 we have another number which is 4. So we're going to continue here. So you can see we have 3 major sections in this graph. So we have this one, the first column Z, and then you have a bunch of values 0 to 9. And then you have again another column which represents 1 to 8, which says add. So it's have what? One value, second value, third value. So this is the first part of the column, second part of column, third part of column. After 7 we have 4. So we're going to see 4. Now we have 4. 4 is represented by 12, which means that we are going to take this part. We're going to add 0.8. This is represented by the first column. The second column 7. And then third column, third value represented by the third column, which is 11. So we're going to add 11. 80, 78 plus 11. We have 80, 89. We're going to take 1 minus 0. This value. 80, 89. Now we can find the probability. 1 minus 0.8089. We have 0.1911. So let's recap. So we need to look at what first? 0.8. So we look at 0.8. After 0.8 we have 7. So we look for 7. And then we take this value 80, 78. We add with, after 7 we have 4. So we look for 4. The 4 gives 11. So we take 80, 78 plus 11. We have 80, 89. Then we have 0.80, 89. We have a second formula. Probability of Z greater than Z, given that Z here is positive, is equal to what? 1 minus phi of Z. I want to find this probability. Probability of Z is greater than negative 1.377. First thing to notice is we have negative value. We have a negative Z. Z is negative. We draw our normal curve. I'm just going to sketch a curve. A rough sketch. Let's locate this Z. We know that Z is negative. So which means that it has to be on the lower tail. So approximately Z can be here. Negative Z. Okay. So we've divided the curve in two parts, in two sections, right? Now, it says greater. So we have the Z here. This is the lesser part of Z. This is the greater part of Z. Okay. So we need to find the greater part. So we need to find this shaded area. If we do a reflection of this curve, we can see that my Z goes on the upper tail and this part becomes here, is it not? Yes, right? So we can say that probability of Z greater than negative Z is the same as what? Probability of Z less than Z, which is the same as phi of Z. We're going to find phi of 1.377. We use the table 1.3. So let's see this first. 1.3 is here. Next we have 7. So 1.3, 7. 7 is what? 9147. So 9147. After 7 we have again 7, which is 11. So we add 11 we have 8, 5, 1, 9. So the probability of this is going to be 0.9158. Number 4, probability of Z is less than negative 1.377. First thing to say, negative. Our Z is negative. Let's sketch the curve. So here Z is negative, so Z is going to be on the lower tail. So we have our minus Z. So again we have two sections. Here is the lesser part, here is the greater part. We need to find the lesser part, so we need to find the shaded area here. So if we do a reflection, we can see that we have this. So our Z becomes here and then it becomes the greater part. So from the diagram, we can see that the probability of Z less than negative Z is the same as what? Probability of Z greater than Z, which is the same as 1 minus phi of A from the result here. This. So probability of Z less than negative 1.377 is the same as what? Probability of Z greater than 1.377, which is 1 minus phi of 1.377. We have already seen how to find the phi of this value. So we have 1, you minus 0.9158. We have 1 minus 0.9158. We have this probability 0.0842. This should have been said here. Number 5. Suppose I want to find the probability of Z lies between 0.345, 1 point. Okay, so we have a positive here, a positive value here. So let's label it as A, B. So basically we need to find the probability of Z lies between A and B, given that A is positive, B is positive, which means that both of our A and B will be on the upper tail. So we need to find, suppose, A and B here. So A, B, we need to find this shaded area. From now on, I'm not going to show you the proof how we indeed get the formula for the particular probabilities. I'm just going to give you the results directly. What I mean is this probability, so whenever you have a probability of Z lies between A and B, it's going to be phi of B minus phi of A. Okay, you just need to identify your A and B and they are both positive or not. Okay, so I'm not going to show you how I got this, maybe in future videos, but not right now. So phi of B minus phi of A. My B is what here? Phi of 1.751 minus phi of is 0.345. So phi of this value minus phi of this value. We use the table. I'm going to keep showing you how we use the table until you understand it well. 1.7. And then we have 5. 5 is 95.99. Okay? Plus, after 5 we have 1. So 1 is represented by 1. So we plus 1, which is this value. So we have 0.9600 minus. Next, we have 0.3. So we have 0.3, 0.34, 6331 plus 5, which is 18. So we have 0.3251. I'm using an old table. I think the table that I sent you is the new one. So To avoid confusion, I'm going to take the same table as yours. I'm going to shift to the newer version. Okay, so this is a different table and you can see that I have 0.3, 0.34. So we have the same value here, but when we take plus 5, we have 19. 6331 plus 19. So we have 0.6350. So we have 0.9600 minus 0.6350. And if we take 0.9600, you minus with 0.6350, you get this 0.325. Two free significant figures, and if we take two free significant figures here, we get same answer. So you can see you don't get different probabilities, you get pretty much the same probabilities most of the time. Okay, so from now on we're going to use this table.